This lesson is 1.1 Algebra Vocabulary. It's important to learn the vocabulary used in algebra since they are what is used to describe how to do the actions in algebra. First, let's relate vocabulary to something you might already know. The key words in algebra are like the key words or the key elements of the English language. When you first started learning the English language, you learned about letters and maybe learned that ABC song. You found out that there's two different types of letters, consonants and vowels, and when you put those together, you made words. When you put those words together, you created sentences, and sentences together to create paragraphs. Algebra is built the same way. The basic elements of algebra are constants, variables, and coefficients. When we take those constants, variables, and coefficients, and we put them together, we'll create terms. As we put terms together, we'll create expressions, and finally expressions to make math sentences, which we'll find out can be one of two types, equations or inequalities. A variable is one of those basic elements of algebra that is what makes it unique to the basic mathematics you've had in the past. A variable is a value that you do not know, or one that can be changed, which is why the word comes from the word varies. In algebra, you can identify a variable as a letter or letters that are sitting side by side to one another. So any letter in the English language can be used as a variable. Look at the directions below. It says to circle the variables in each algebraic expression. Wow, there's a word that you saw before, expression. We'll get to that in a minute, what expression means. So let's look at these. Can you find the variables? They're pretty simple. They're just the letters. So in this first example, oops, I almost circled the 4. A 4 is not a variable. It's just the x. There, that's better. In the next expression, y plus 12, y is your variable. And in the last expression, oh no, I'm not to the last one yet. The next expression is 9z plus y. The variables in this expression are z and y. And in our final question, we have 8 over w plus 4w. This expression has two variables, just like the last one, the w's. The next word you see is coefficient. Go ahead and say it a couple of times. It should put a little puff of air in your mouth as you say it. Coefficient. The word coefficient starts with the letter CO. If you don't know about the English language, there are a lot of what we call prefixes in front of words that mean something, and we can cut them off of a word, and what we have left over is a word you may have seen or heard before, efficient. So co is a prefix. There's some other words in the English language that you've seen before that start with the letter the letter CO. How about co-worker? Cohabitation. And coexistence, just to name a few. If we cut off the CO off of any of these words, then we get another real word. If we cut off the CO of coworker, you get worker. Cohabitation, you get habitation. And coexistence, you get existence. Now, CO is only a prefix, as if when you cut it off, what's left over is still a real word. For example, the word coffee, it may start with the letter CO, but if you cut it off the CO, you get fifi. That's not really a real word. So co is not a prefix here. So why am I spending so much time explaining what a prefix CO means? Well, let's look at the relationship between these three words. Co-worker is somebody you work with. Cohabitation is somebody you live with. Coexistence, something that exists with something else. Notice as I was explaining each one of these, you hear the with, and with. That's the same thing with the word coefficient. It means with something. That's going to help you remember what the definition of a coefficient is. A coefficient is a number that's with a variable, or a number that multiplies to a variable. In algebra, when we show multiplication between a number and a variable, they sit side by side to one another. Let's take a look at some examples. Here in this example, 5x to the second plus 2xy minus 3y plus 4. The numbers that are with our variables, let's take a look at them. The 5, the 2, positive 2, the negative 3, those are with variables. That 4 is not with a variable, so it's not a coefficient. The 5 is sitting right beside that x to the second. When you see a number right next to a variable, then it's called a coefficient, and the operation that's going on there is multiplication. You could say 5x to the second, or you could also say 5 times x to the second, because it is multiplying to those variables. Now, all coefficients have signs to them. If you do not see it, then the sign is positive. I'm going to go ahead and write a plus sign in front of a plus sign in front of that 5. We don't see a sign in front of it, but we're going to assume that it's positive. It's sort of like if somebody asks you, how much money is in your pocket? Do you say, I have positive $5 in my pocket, or do you just say I have $5? You just say $5. It's implied that it is a positive number. There you have x, y, those are two variables, and right in front of it you have the positive 2. And then the final coefficient that you see there is the negative 3. Make sure you understand that signs always go with your with your coefficients. So all coefficients do have a sign. When I say sign, I mean positive or negative. You also must remember that all variables have a coefficient, a number that's with it. If you do not see it though, it is the number 1. So the coefficient of 1 is usually not written. It's the same thing when I was talking about that money in your pocket. If somebody asks you how much money is in your pocket, do you say I have $1 or do you say I have $1? Everybody knows what $1 is. It's just one of them. Same thing in algebra. If you ever see a variable, let's find one here, like the x, y's there, the two variables put together, there's a coefficient that has to be in front of it. We don't see it, so we're going to assume that it is the number 1. And like I said before, all coefficients have a sign to them, so that variable has a positive 1 coefficient. Do you see any other variables that have that hidden or invisible coefficient? Look at the y. What's its coefficient? You don't see it. It's that invisible 1, and it does have a sign to it. It happens to be a negative 1. In basic mathematics, you probably heard of the word product. That's when you multiply two numbers together, and it's the answer is the product. But do you know that the two numbers that you multiply together also have a name? It's called a factor, or they're called factors. Factors are the numbers that you multiply together in a multiplication problem. So, for example, you have 4 times 5 equals 20. The 4 and the 5 are factors of 20. Now, there's more than just one pair of factors sometimes with numbers. So let's take a look at the number 25. What are all the factors of 25? Well, if you multiply 1 times 25, don't you get 25? So 1 and 25 are factors. How about 5 times 5? Also equals 25. So 5 is also a factor of 25. Let's look back at that number 20. What are all the factors of 20? I'm going to write the number that I'm trying to, what I call factor, up at the top. Well, 1 is always a factor of any number. So 1 and 20. How about 2 times 10 also equals 20. How about 4 times 5 is also equal to 20. And those are it in all of them. Now, how would I know when to stop? When do I know that I have all my factors? If I write my factors as pairs, like you see here, side by side with the smaller number on the left and the bigger number on the right, as long as the numbers on the left are not bigger than the numbers on the right, you can keep on going. But if you look here between 4 and 5, let me change my pen color here so you can see, 4 and 5. Each time you're finding your factors, you're finding numbers that are in between the two numbers that you started with, like the 1 and 20. 2 and 10 are both in between 1 and 20. 4 and 5 are both in between 2 and 10. But are there any numbers between 4 and 5? There's not. So that's how I know I have all my factors, or factor pairs. So let's look at our second example. What are the factors of 7a? Now you're probably thinking to yourself, I don't know anything times 7 other than maybe 1. Well, if you have a variable, you could say 1 times 7a is also equal to 7a. Remember that 1 times anything equals itself. Or you could split it up. Remember, when a coefficient and a variable are together, then that means multiplication. So 7a are also factors. Since x is the most used variable, you will not use x to show multiplication anymore. There are other ways to show multiplication. When you're trying to write factors of constants, remember those numbers? This is what you've done before. If they're both constant, then you can either use a dot, like, oops, sorry, I was trying to write, like the one you see there, or you can see use parentheses. Now this can be confusing sometimes, but yes, in algebra, when you only have one number or variable, or in just a minute we're going to learn about terms, inside parentheses, then you will multiply the number that's next to that parentheses. Factors of two variables you can also write 3 different ways. Now, you could use the dot just like what we use with the constants. You could use parentheses. But the most common way, kind of like good, better, best, is just to write the variables side by side to one another. So this is what you're going to see most often. Now technically, this does mean the same thing. Just like if I said, what's the answer to 2 times 4? Isn't it the same answer as 4 times 2? Okay. So yes, they can be written in a different order. But it's also like saying, my name is Stacy and Stacy is my name. You don't usually hear that second sentence. Just like when we put variables together to show multiplication, we will generally always put the first letter in the alphabet first and then the next variable afterwards that's later on in the alphabet. So if you see an x and a y together that you're showing to multiplication, you put the x before the y. When you're showing factors of coefficients and variables, you could still use the dot. This is the most common way you would see, though, is to write the coefficient with the variable right beside it. And this is just trying to show you that if you use parentheses, yes, here we have this x, and it's showing the multiplication of 3y. Those are the factors of 3xy. So when you're showing multiplication between coefficients and variables, you will always put your variable first, your coefficient first, and any variables afterwards in ABC order. So the most common way that you will see coefficients and variables multiplied together is putting the numeric coefficient first, then your variables, your letters, in alphabetical order. A shorthand to show factors that repeat themselves is an exponent. If you want to show multiplication of the same number over and over again, you will write a little number up in the air to show how many times it's being multiplied by itself, not by the number up in the air. That's the most common mistake. So if we have 6 to the second, that means the same thing as 6 times 6, not 6 times 2. Notice you will get totally two different answers. If you took 6 times 6, you will get 36. Notice I used that dot there. 6 times 2, though, is 12. So there's a big difference between 6 to the second and 6 times 2. If you see a variable with an exponent up in the air, you do the same thing. X to the second means x times x. We could do x times x to show it, or you can do x times x to show that multiplication. Either way is equal to x to the second. Our final word that's part of our basic elements of algebra is a constant. Now you're really familiar with a constant. It's just simply a number that does not have any variables with it. Up until before you took algebra, that's all you ever worked with was constants. Constants have a fixed value. That's why they're called constants. They stay in place. So here's an example. You see 5x plus c equals 32. Our constants are any numbers that do not have a variable with it. So the 3 does not have a variable after it, nor does the 32. So those are both our constants. Oops, Sorry, I also wanted to make a note. Constants also have a sign to them, just like coefficients do. They're either positive or negative. And again, if you do not see a sign on a constant, then it is positive. So constants and coefficients, those two C words, always have signs to them. If you don't see them, make sure you put that positive sign with them or note that they are positive. Well, once we take our variables and our coefficients and our constants and we put them together, just like letters we put together to make words, those elements we put together to make terms. Terms are separated by plus or minus signs. So here in your example, I see a plus sign here, a minus sign here, and a plus sign here. That lets me know when I have a new term. Just like in English, we use a space to show when a new word is about to come next. So here's our terms. 5x to the second is one term. Positive 2xy is the next term. Negative y. And then positive 4. Make sure you put the signs with their terms. Signs come in front of a term, not afterwards. So one thing you don't want to do, let me erase all this, is call 5x to the second plus a term. Remember, the signs come before, not after. If in what we're going to learn in a minute what an expression is, you have variables and constants that are the same in a term, then they're said to be like terms. It does not matter what the coefficient is, though. Alright, so let's take a look at an example here. I see 5x to the second. So all we're looking at are the variables in the term and the exponents in the term. The coefficient is 5. We don't need to worry about that, but look at the x to the second. Do you see any other term that has an x to the second in it? Yeah, 4x to the second. So those are both like terms. They both have the variable x to the second power. So how many terms do we see in this expression? I see 4 again. 1, 2, 3, 4. So our second term in this expression has an x and a y variable in it. But I don't see an exponent. Just like a coefficient, if you don't see an exponent, then its exponent is 1. Now, I don't recommend you put a little 1 in front of on the top of every variable that you see or don't see. just know that it is to the first power. Do you have any other xy variables together? Yeah, right here in the third term. They both have an xy in them. So those are also like terms. It's sort of like in a family. People in the same family all have the same last name, right? Doesn't matter what their first name is. Same thing with terms. Terms are not like, or kind of in the same family, unless they have the same variables with the same exponents in them. It's also important to know that constants are always like terms. Let me just write a couple numbers down. If I say in order to have terms to be alike, they need to have the same variables and exponents, what are the variables that are with constants? Well, there isn't any. That's the whole definition of a constant. Well, isn't not having a variable the same thing as not having a variable? So we have no variables with no exponents on them, so that's why constants are always like terms. Okay, so you take your constants, your variables, and your coefficients, and you're putting those together, you created the terms. When you put terms together, you create an expression. Kind of like a sentence. Words make sentences. There are two types of expressions, algebraic expressions and numeric expressions. Now, in basic mathematics, you've worked with numeric expressions. Those are the mathematical phrases that don't have any variables at all. Let's see if can you identify them below. I see this one right here, and that appears to be the only one that has. So you've done something like that before, 11 plus 5. That's a numeric expression. All those other ones, if there's even just one variable in there, then they're called algebraic expressions. So we'll put an A there. So just like expressions can be algebraic and numeric, I should go back and let you know that terms can be algebraic or numeric. For example, 2x plus 3. The algebraic term is the one with the variable, and the numeric term is the one without, or basically just any of your constants. We're going to you need to make sure you can identify variable terms and constant terms, because you're going to be doing something with them later. So algebraic and numeric expressions, the big thing to know what makes an expression is the fact of what it doesn't have. An expression does not contain an equal sign. But you can take expressions and put them together to create math sentences. A math sentence is joined by expressions by connecting it with an equal sign, a not equal sign, a less than, greater than, less than or equal to, or greater than or equal to symbol. So here's some examples. We have an expression connected to another expression with an equal sign. The 5 times 2 is equal to 10. That's a math sentence. On either side of that math sentence, you have an expression. Now it's just a little short expression containing just one term. 2x equals 7 is another math sentence. It's an sentence because it has that equal to sign. Now on either side of that sentence, there is an expression. On the left side, the expression is 2x. On the right side, the expression is 7. Expressions can just be one term long, but generally have more than one term. 5 less than or equal to x. You have an expression of 5 on one side, that constant, and on the other side, on the right side, you have just the variable term, x. Now, math sentences are usually described by which type of math sentence you have. You don't generally hear somebody talk about math sentences. Instead, you hear one of these two words. An equation. An equation is a math sentence that contains an equal sign. An inequality is a sentence with one of the following symbols, either the less than or equal, or this is the not equal to sign, sorry. The less than, greater than, less than or equal to, or greater than symbol. So your two types of math sentences are either an equation or inequality. In this course, you're going to learn how to solve equations and inequalities. Alright, it's now time for you to work on your guided practice. Turn to your guided practice page and answer as many of the questions as you can on your own. When you're ready to check your answers, then go to the next video to go over the guided practices.